Hello, everybody. So, started off today with a quick visit from Career Link. Make sure you take advantage of that department. That's why we're here. One thing I know that they don't usually say that I really like to do on resumes. You mentioned that. One thing I found I like to do on resumes is most companies have a company color, which you can find on their website. And if your resume just happens to use that color for all the accents and stuff, or something very similar to it, it kind of helps to look like you belong to that company. Little things like that can be very helpful. Color is a big aspect. We'll talk about color theory some, or at least try to mention it. We have a lot to squeeze into class. Today we're going to finish up our PyGame section. So it probably doesn't look like we're as close as we are. There was the little sidestep answering a question the other day, which I was actually really happy with. Is there's because of that stuff we did the other day, which was probably a little bit confusing. I sent out the files so y'all can go through and analyze them. It wasn't exactly following along because I was just making up that algorithm. There's more than one way to do stuff in code, right? Multiple ways to make the machine do stuff. If I made up the same thing today, I would probably make it up differently, some slightly differently. Uh, Game development is an extreme example of that. You have to be careful looking at examples because of it. There's so much intertwining between things. It's programming. Programming is problem solving. Every problem is a new problem. What we did before might help us, but there's no guarantee that it will. Right? It might be completely different because of just something that seems so small and trivial to us throws everything off. So when you're looking at examples, follow along YouTube examples and tutorials and things, be careful to watch out for that. A slight change can make a big difference, like scales up and escalates. But from that thing we stepped aside and did the other day, it created a really nice separation between the programming language and the game engine. So I want to explicitly point at that. Hopefully you kind of noticed it, at least in the back of your mind. And then we'll get back to the base level follow along. So it'll be simple stuff because that question also led to another nice little, well, a nice little story for the game popped in my mind. This is the arbitrary thing I had in mind. So that was a great question, by the way, because it provided a better example on stuff. I know it was a little confusing, but it showed a better example of what the overall process is than what I had in mind for the introduction section, which made it confusing, but it's there for y'all to look at. And I thought it kind of lended itself to a storyline to finish out our game so we can see how those go together. So let's just jump in and kind of look back at what we had. So I've been using idle the last few days. Are you all okay if I use a different text editor? We have lots of places we can type Python code. So everybody does have a place they can type Python and follow along, right? Right. I'm going to use my preferred text editor this time. So Sublime Text Editor. So here's what we've got so far. We have the PyGame, the game engine, initialize stuff, and then we use that for a clock and how we're handling our key presses. This is just a couple numbers that we might use, but then we turn around and use them in something from the game engine. But the example the other day, when we get down to our main loop, we did some setup and stuff, and we're looking at events. Our game engine handles the events, the key presses, the timers. The next thing we're going to see is when stuff bumps into each other. We'll set boundaries on things around a character and like a little gold coin. Collecting gold coins is not a nice non-violent thing we can do in a classroom. And then when those boundaries intersect, the game engine will handle that for us. Then we got down to that stuff that was probably confusing the other day. If we look through this, all of this is pure Python. There's nothing from PyGame here. We have if-else stuff, and then we have some booleans and variables holding numbers. There's nothing from the game engine here. And then right afterwards, we have the game engine put the images on the screen. So notice the game engine just has those basic components. The game engine knows what knows how to put graphics on the screen, how to listen for the keyboard event. And then anything else that happens, we just use our regular programming language to do the other part. So that example made a really nice separation. I know it was hard to follow, and we kept hitting bugs. I do like to do that at least once, go through something unprepared, so that y'all see that the class examples we normally go through, where I practice them ahead of time, isn't how coding goes. It's like how you're used to, where typos constantly happen, and we have to adjust our logic and a lot of back and forth. But that I don't like to do that more than once I don't like to do that too many times in a classroom, because it does eat up a lot of class time, and we don't have very much class time, right? But notice the separation. That's an important one. And this is what we do a lot. We have the game looping over and over and over and over again. So we just need to check the state of the game. So that's usually how these end up looking, just lots and lots of conditions that we're checking over and over and over again. And this one took me a long time to kind of figure out, to just set Booleans and adjust those Booleans. I used to try to make big, messy conditions of everything we're checking. And that kind of makes the code look like a mess. So that's just a tip I've learned along the way. Go ahead and just set everything to a Boolean and use that as your condition, and it makes the code a lot easier. Tips for today. But take note of that separation of what the game engine does. It handles our graphics, which basically just puts the graphics on the screen, and it handles the event, and everything else is on us in the programming language connected to the game engine. That's a consistency we'll see across several engines. If I go ahead and run this now. May not be what. I'm getting ready to change the name of it too. So I did kind of come up with a storyline. So we have this character walking around on this map. We can go east and west on the map. That's kind of like the US, right? So that did give me an idea for a storyline. Because really what we're doing with the game is we're going to tell a story. The story is what brings the player in and catches their attention, keeps them interested. A few games have got by without a story. Tetris, but unless you're making like the best, what many people will argue is the best game ever, you can't really rely on being able to get it by without a catchy storyline, some sort of story to tell. Even the knockoffs of Tetris had to have a storyline, like Dr. Mario and a whole bunch that showed up as Facebook games, but over the years, but they still had a storyline for why those blocks were falling and disappearing. So some sort of plot. We'll talk about creative writing things at some point this semester. It's actually the main discussion on that's later in the semester, but we're Americans. I think everybody's seen enough TV shows and series and movies to have the basic idea. You know the basic idea of telling a story, right? You introduce it, then you introduce your characters, throw your characters in some sort of horrible conflict, and then you resolve or absolve that at the end. We'll talk about those in more detail later, but because of that math thing we did the other day, I had a thought for a storyline for this. I was going to collect gold coins. So what if our character's way over here in the eastern US, and like 1849, there's gold in California, and the Rocky Mountains in between there make a nice little maze to get across. Like it's just a storyline. Or if we had more time, which we don't have time, the way it's scrolling over South America and all around, we could come up with, that's the game the player has to get from like New York to California to try to find gold. Some sort of storyline. So we want to turn this into that game. So that's what I came up with a storyline for it. My notes here say we'll just use a coin. Coins are easy to draw, right? A yellow circle, and we just say it's a gold coin. We'll set that and then add in collisions, which definitely want to be done with that before the break. I'm sure I can be done with that about 10 till 2. And then we can go through the same thing a whole lot quicker with like some gray triangles to represent mountains that we'll put on there. Not a real in-depth maze at this time. This is the first draft, right? The in-depth maze is like the fancy graphics on the character. That comes later. That's very time consuming. But once the graphics are moving around the screen properly, then it's no trouble to replace them with better graphics later. Once we get a basic position for some mazes, we'll do mountains to create a maze to go through. We'll have that, and then we'll set up a cutscene where when we start the game, we start with a little introduction, tells what the storyline is and all that, and then an outro cutscene. Actually, we need 2 cutscenes. We need one for the player doesn't make it, and one for if the player does. Not anything fancy, but that's the plan for today. So first thing I'm going to do is save this under a different name. Probably maximize it on the screen. That way it's a little bigger. Now that I have a storyline, I'm going to call it 49er.py. So like the 1849 gold rush across America. Sounds like a good plot to work with. Yeah, I just told you all what we're getting ready to do. So the first thing is we need a gold coin. So I'm going to open up Inkscape and make a gold coin we can use. And when you're on the programmer side, right, if you're a programmer and there's an art department that's going to do all the fancy stuff, the biggest thing for us to worry about is the size of the image, because we want to program based off the size of that image, and then when the really good artists have had time to make a really, really awesome image for us, we just want to make sure it's the right size and the right name. So that's what we need to worry about here. Coin's fairly easy. We just need a circle. So I'm going to grab the pencil, and I'm not even going to use circles, but I'll draw a little circle and try to choose a gold color here. Because that storyline, it's not a minted coin, right? It's probably something more like a gold nugget fit in that storyline. So something goldish in color, and probably just take this, copy and paste, and move it over just a little, down just a little, and make it a darker color. Move that to the back. Over bottom. There we go. That looks like a coin. I guess I could put some sort of picture on it. That'll work for our gold coin, right? Don't need anything super fancy. But this is the working image. So the main thing we need to worry about is the size. Our character was 64 by 128. So realistic size would probably be down for a gold nugget or gold coin would probably be down by 3 or 4 pixels, but that would be way too small for the game, right? Be too small to see. So I'm trying 64 by 64. Then it's a nice big thing. We can see that white line of where the file is. So now I'll just select everything here and resize it the same way. Set it to 0, 0 on the position, and then 64 by 64 on the image. So again, the main thing, and then I'll save it in the same spot as the other images. And that's from the programmer's perspective when we're just putting together our initial images. And I do more than some people. Some people swear you should start with just square blocks and circles, because same reason stage magic can be entertaining. A little bit of distraction goes a long way with humans. And the tiniest animation will hide the biggest of bugs. We won't even notice huge bugs in our program because our characters like breathing in the idle animation. The character's doing that, and then we don't even notice what's happening behind them. So watch out for that. Some people swear to start with just rectangles and circles to help with that a little more. I like to have something that's at least the right colors, and but the two big things you need to worry about from programmer side are the name of it and the size, and then tell the art department what to name the file and how big to make it.
How big was the gold nugget for everybody?
I made it 64 by 64 nugget. Now loading that on the machine is same as what we've seen before. Got a player and background, so I'll add it in here. The nugget sprite is PyGame.image.load. Really just making typos is a human trait. I probably should have just copied from that earlier line and make slight changes to it, because I already know the earlier one doesn't have a typo in it. Computers never make typos, so I recommend copying and pasting as much as possible, using that predictive text to fill things in. That's part of what I was getting. What is missing in idle? If you're using idle, control space, or on a Mac, it's actually control space as well. It's not the transition to Mac. Control space pulls up the predictive text in most IDEs. So there's our image. Then we'll need some coordinates to put it at, which we always need the X and Y coordinates together. We need both of them. And usually we're going to refer to them together. So it's best to do that as a list or a kind of a vector in the way we're using it. But a list as far as Python's concerned. I'll enter it over and 270. I think that's about halfway down the first screen. I don't think we have time to completely finish the game, but we'll get enough that we can tell what's going on. And our character should probably start on the Eastern US, but I'm going to avoid the whole screen rolling thing and just go one screen over. So maybe like 723 is almost across our screen. And I was looking at the number up here. Always have some notes down or know where to look at the numbers you have elsewhere in your code to keep track of things. Over the years, I've found it's really helpful to go ahead and have some notes, like we have the screen drawn up, and we have the size there. Screen share, so this is bigger for those involved. So our little gold nuggets over here at 100 pixels over, and I think I put it 270 down. Now our characters up here at 723 over, 123 down. In a little picture like that, it doesn't have to be perfect, but get the idea. And well, when we add something else in, like the mountains, it helps to narrow down where that first guess is going to be, what number we should be using. That can be really helpful, and it doesn't have to be a neat sketch. That happens so much in the classroom, right? There's always homework assignments on that planning part, right? Turning your UML diagrams and your pseudocode, and you want to make it look all fancy and formal. But that part it's more productive when it looks like a mess. Right? That's the one that has things scribbled out all over the page, and or if you use a pencil, things have been erased so many times you can barely read the final version. The one that looks like a mess is going to be more productive for you. Classrooms tend to throw that off. All right, now we can throw that on the screen. In front of the background, and should we be in front of the player or behind the player?
What's the question again? Sorry.
Should our gold nugget be in front of the player or behind the player? So when the player goes over there, we're still a step from the interaction. Do we want the player to cover the nugget and then we react to it? Or do we want to see the player behind the nugget so it looks like he grabbed
I think we both look like they're grabbing it too.
it? Either way,
If it'll happen fast enough.
yeah, it's going to happen pretty quick.
I would say over it, so it looks like they cross over it and pick it up, but you can do either one, right?
Yeah, either one would work. That's why I was asking for your all's opinion. And we know how to put it on the screen now. The block scene.blend. And scene was what we called our display area. That's just a useful name we made up for what the thing in PyGame. And we want to flip the nugget sprite to the nugget chords. Trying to put semicolons in because we don't need them. I guess now we can probably just run it. Whoops. See if it works. So Python, if you're on a Mac or Linux, remember you'll need to type Python 3 since Python 2.7 was used in those operating systems. Run that. Oh, I renamed it. 49er.py. Probably need to. It looks like my guess on the height was a little off on it. I think the gold rush was Central California, right? So a little bit north of there. That character looks like a good place for the character to start. That's somewhere around St. Louis. That's where people left from. So if we move that, and there, you'll find there's a lot of that. Right? Your first one is just a guess. 100 over 270 was way too far down. So let's try 170. Save that and run it again. Maybe 100 is too far over. So 80. Whoops. Zoom button popped up when I went to click on my screen. Maybe we could go even further than that. Let's go on like 40. And this is something we do a lot, right? We just guess on the first number and then we just adjust it until we find where we want it to be. So run it over and over and we'll get there. That looks like a good starting point. So now our character is able to run over here. It's facing the wrong way though. We need to turn that around. Do you may think we need to draw another image for that? Or
It should be a function.
There's a flip, but I was going to tell where flip comes from because we don't always have flip. I think there is a flip in PyGame, but what it is, yeah, since he mentioned that, we'll use flip. But where that comes from, I'm on the board here. So we have our character, or like a stick man, he's kind of facing that way. And we can scale that, right? We can make that smaller. Like in particular, we could scale it in the X direction. Scale it down by 1/2. And then we have the same image squeezed in kind of flat. And we keep going and going. We get to 0, but then we go to negative numbers. Right? So if we scale it in the negative direction, it squeezes all the way down and then starts to fold the opposite direction. So sometimes some game engines give us that flip option, but all that flip method does is scale by negative 100%. And our character turns around and faces the other way. That's one we always have, but since it's like one line of code to do that, most games, a bunch of game engines did that. I guess just filling time, but it's one line of code to do that. So I would say it's probably somewhere around 50-50 on whether or not a particular game engine has. That's what it seems like to me over the years. A lot of people went ahead and typed that line and gave it a useful name. And a lot of other people that made game engines were like, it's one line of code. There's no need to abbreviate that. But names can be useful. In PyGame, we do have a flip. So we could just I'll scroll to where we're gonna do I'll just go ahead and say it. I was gonna ask a question, but I already scrolled to where we were gonna do it and put my cursor there. Just kind of gives the question away, answer away. When we move is probably the best place to do that, right? So if we push A, that's left. We want to flip our character if it's not already flipped. Because if we push A again, we don't want it to flip back. Right? We want to keep going left. We don't want that to happen the first time. So this is something a good spot for a Boolean. Player left is our player starts facing right. So a variable called left is false. And over the years, I found it's more useful to always call the Boolean left, because otherwise you end up with the word right in there. And because of the multiple meanings of right, there's other places where the word right could show up for a Boolean. I've just found left tends to it makes more sense in the code when I come back to it like a year and a half later, trying to figure out what we were doing when we wrote that code a year and a half ago. Over the years, I found calling the Booleans left and instead of right make more sense. So we press A. So if not player left, if we're not facing to the left, then we want to flip that image. So player sprite, and just type dot flip. It is just dot scale, and then we want to scale it by -1. But since we have flip in PyGame,
should be like a transform flip.
I mean, what I was getting when I was getting prepared. No, apparently I didn't flip the one last time. There's a number that goes in there, but it's probably a good time to check the docs. Explorer the browser and flip image PyGame, because this is what y'all are going to do if you write something in PyGame, right? We're going to finish up PyGame today in class, and then okay, yeah. So I was trying to use surface is what our images are called. So I was trying to do surface.flip, which is what we will have in the game engine we get into next week. This one we say flip and then tell it what surface to flip. And it looks like we pass in some booleans. So turn left and right, I think we want true X and false Y. Y'all know that process, right? Which I did remember it. I was trying to do the surface dot flip, but it's right in the module. So PyGame dot transform, which is also where scale's at. Location, rotation, and scale. We're going to talk about those a lot next week. That's transform data. That's that's really what we're doing. I just decided I wanted to do this stuff once before we talk about what transform is. So you can see how much we use. But flip is the scaling. So we want to flip the player sprite true on the X axis and false on the Y axis. And then we want to set our Boolean. So now it's facing left, so we want to set player left equal to true. With a capital T. It's Python. And we'll do the same thing when we turn back to the right. Almost the same thing. Where does it need to go when we turn right?
Where we have the like a key that says go.
D.
Yeah,
This one?
perhaps
Oh, D.
D.
yeah, D.
So we'll flip on the x-axis, and now player left is false. That way, it'll keep flipping on us. Best rule of thumb for programming is run a check every chance you can. Especially if there's only one line. If you've only wrote one line of code, that's the best time to test, because if it doesn't work, you know exactly which line of code went wrong. Oh, it didn't flip. Or is it flipping too quick? Nope. Did I type something wrong? I guess I should have left that open. Flip image PyGame. PyGame transform flip.
What was the surface used image?
The player sprite. Where the official docs aren't shown, there it is. So this is what I was gonna do, this, which is right below it. PyGame to transform flip. Surface flip X flip Y. Let me see if scale works.
The scale will just make it a difference.
Yeah, so this is the one that, this is what is in that flip method. If you went and looked at the source code, it says take that surface and flip it by negative 100%. Or this one would be back to the positive 100%. Location, rotation, and scale. Those are going to be very, very important coming up soon. Save that. Give it a run. Oh,
This is about parallel. Again, don't know if that has to do with anything.
size must be two numbers.
That
Oh,
has to be the
I need the
coordinate.
X and Y. Yeah.
Like,
So -1 in the X, 0 and 1 in the Y, because we're not changing it. And then down here, when we go back to the right, the normal +1, it's even like that better.
yeah, scale and size.
Okay, I'm just gonna erase this and
I think it wants an actual size to give the same pixel wise.
oh, pixel.
I think so.
Oh.
Like if you say you want the image size to be 800 by 800.
I'll go back to the flip. Maybe I can make it PyGame. I don't use PyGame very often. Actually, I think the last time I used it was when I taught this class last fall. It makes a nice, easy introduction. So we look at the flip method. This one.
Are they supposed to? I mean, it says if player not flip. It's supposed to do that twice.
Oh, we have to assign it. So that's what that little arrow means. It returns something, but if we don't save it, we're not going to continue doing that. So what we had here, we're going to take the player sprite and flip it in the X. but not the Y.
Oh, let's see.
But then it just does that. We need to save that somewhere. So let's make that our new player sprite. And next week, when we get up to
Yeah, like they-
oh,
oh, yeah, there's-
which probably happened twice because I copied and pasted. There we go. Wait, why is he not flipping back? Did I put it in the wrong spot? Oh, yes. That is the problem. Thank you. If we are going left, then we'll flip again. Okay, so we face the right direction now. And we can get over there. Oh, that went a little bit too far. I'm going to change the condition for where so I'll do -20. We can't go, we just won't go past there. Which really that, I'm just ignoring that part for now. Oh. Hey, we're not gonna go that far off the screen. We're not gonna go 20,000 pixels off the screen. So that gets us there. Up 3 minutes behind what I was planning on. But we've seen that before, right? No real surprises there. The flip, y'all know how to look stuff up, make little changes. Really, right now, we're just ignoring this part, kind of punting it down. Like, okay, we'll fix that later in a better draft of the game with fancy conditions so that we don't do it when we're all the way at the left of the map. We don't need to keep going further to the left. But for our tight time constraints, I'm just going to ignore that. But again, notice there's a huge separation of what the game engine does and what the programming language does. The game engine basically just takes the graphics and puts them on the screen. Anything that we want to happen with them beyond showing on the screen is stuff we have to do with just regular Python code. And bounds. So bounds are built into every game engine. So we mentioned this on, I think on the first day. This is what we actually need from the laws of from the physics engine. Most physics engines, or most of the popular ones at least, have been building for many, many decades. So they have basically all the laws of physics built into them. But what we really need is the collision. Right? If I lean against the wall here, the laws of physics happen where my hand is making contact with the wall. So we just need those boundaries. I'll call it player bounds. And the game engine gives us a nice way to do that. In PyGame, our syntax is a PyGame dot what do I use here? Am I looking at the wrong thing? Sprite.getRect. It actually gives us more than one way. This is probably the easier way. So we want to look at something about the sprite, and then we can say get underscore rect. So we have that whole image, right? Our player is 64 by 128. So it's going to take that size and then just use that outer rectangle, a 64 by 128 rectangle. And same thing for the nugget sprite, or the nugget bounds. is PyGame.sprite get the rectangle of that image. So now we have a boundary on it. For those who have been through at least the 140, how many people have had the SDEV 140 class for
I
high?
think
Whenever I do that, it just doesn't. PyGame.sprite.get_rect. It remains the color of nothing.
I'm not sure. Mine recognize it. It that is the correct words. It's not a capital R, is it? Nope. All underscore. Oh, that is wrong. Let's use player sprite. PyGame doesn't know exactly which. That's the library it's in. Sorry, I looked at the wrong spot. I'm at it. We don't want the generic library. We want the actual object. We want the actual sprite we've already created.
Okay, now it knows what the hell it's talking about.
Sorry, I looked at the wrong. I looked at a comment on my notes from getting prepared instead of the actual thing. So we're just using the edge of that rectangular picture. That works as long as there's not extra space. Sometimes we don't always want that, right? Like if we're in a fighting game, we don't want the boundary of the image of our character, even if it's up tight against the character, that's not where we want the punch to happen. Right? We only want to interact with the punch when it's like square on the player's face or something. Oh yes, and I started to ask, well, I said the 140 class. How many people have got to a programming class where they've seen object-oriented programming before?
Well, I did it with PyGame.
Okay, so from these things we have on here, hopefully you can see already that an object would be better for those three things that we put in the game. We could do basically the same object for all three of them and not have to keep rewriting that same code. I don't think we're going to have time to get into object-oriented stuff. It depends on where we're at by about 3:30 today. And I don't think we're going to get there. But for those who have seen object-oriented programming, hopefully you look at those lines of code from like 13 down to 29 on my screen there. It's like, oh, that should probably be an object. Video games pretty much entirely switched to object-oriented programming quicker than anything else. It's a style of programming. We create our new data types. So like we have integers and booleans here, a type of data we're working with. We would create a new like player type of data that has that has all of those components in it. It was invented in the early 60s when like the government research analyst in Norway, who had probably the nicest computer on earth in 1962, object-oriented programming worked then. There's a lot of extra overhead. It's something it makes for a style of programming that's better for the programmer. It's way worse for the computer, but it's so much better for the human that's writing the program. We can do a lot more. By about 1985, 86, what we would call the average computer could handle it. And pretty much the entire industry switched to object-oriented. For the most part, y'all have probably never even heard of programming languages that aren't object-oriented these days. It's just so much better for the programmer and the extra works on a computer, and there hasn't been a computer complain about the extra work yet. So we don't mind giving them the extra work. Video games took to it quicker than anything else as well, because it just fits. We can think of that object, that thing we're creating, consolidating everything together as a game piece. Like on the classic board games, those little plastic pieces. And think about putting everything together in one piece instead of having, like here for our player, 5 different variables to keep track of. But variables to keep track of. So that's something that's very important because we don't want to move our image and leave our boundary behind. It's on a map, right? We don't want the image of the player to go to California and the boundary of the edge of the player to still be in St. Louis. Not very useful that way. So we have to make sure they move together when we do it this way. So anytime we're moving, that what I do here?
Would you
Okay,
do
yeah.
a coordinate for them and just move that coordinate around with it, or?
Yes. That's what I was getting ready to do. I was just saying about making sure I did it the same way I did it when I was getting prepared. So we have to put those at some coordinate, right? Here we have an image, a rectangular shaped image, and here we have a rectangle the same size as that image. So we just have to put them at the same coordinate. So down here, we adjust all our player coordinates. Then we get down here right before we put it on there. This is probably a good spot to adjust the boundary, make sure the bounds are at the same spot as the player. So player bounds, and here it's just .x. The rectangle is an object. I was talking about object-oriented programming, so some of y'all might recognize that. For those who haven't, you've seen the dot and then something else, right? That's object-oriented. So like this scene thing, there's a bunch of things to it. Glyph is one of them. One of the things about players is .x. Obviously a .y as well, right? Player.x is the player chords, the x coordinate, and player bounds .y is going to be our y coordinate. And we'll do the same thing for the nugget. It's not really moving, but before long, we're going to have it in slightly different spots. Or, well, we might run out of time for that today. But before a final game, we would have that in different spots each time. So we'd have to take a different route through the maze to get to it or something like that. Nugget bounds.x is the nugget chords x coordinate. And again, computers never make typos, so it's a good idea to use the predictive text as much as possible. That'll be our nugget chords, the y coordinate. And since it's not object oriented, would make that a lot easier because then we could just consolidate them and move that object. But here we have multiple variables to keep track of. Now we should see them bump into each other, but we will probably want to do something when they bump into each other. So I'll do that up here with the checks. Maybe all of the events. So after we check the user input events, the next important event is probably what we often call is collision. And we have the same types of collision, same things with collisions that we do with keyboards. When we first press the key, when we're holding down the key, and when we release it. The generic terms that show up most often across lots of different game engines are going to be enter, stay, and exit. So like the key press, when we first touch the key, that's the enter. Or with a collision, whenever the two things first bump into each other, that's enter. The whole time they're in contact is the stay, and then afterward, the last instant that they touch each other is the exit. Or actually, the exit is the first instant after we stop touching. On the keyboard, that's when we release. So that first instant that we let our finger off the keyboard is the exit. Same thing when images collide. And we have this built-in method with the rectangle that can check for collisions, and it returns true or false. So then we can just put it in a if else block to check things. So if our player bounds dot collide rect, different people made PyGame and they spelled their variables different. Y'all have probably noticed that by now. Some things have capital letters, some things have lowercase letters, some things have underscores, some things are spelled out, some things are abbreviated. Whoever made this one just spelled one word out and only half of the other word, and
That's the problem with open source stuff. You get weird things.
yes. Unless somebody takes time to do it. So like when we get to Godot at the end of the semester, it's open source, but there is one person who is responsible to go back and make variable names consistent. So people can call it whatever they want before it gets released. Somebody's going to make it match the naming conventions.
That's good.
And what do we want? What are we worried about colliding with? And the only one we really care about is our nugget bounds. And we would do that for everything we're worried about colliding with. So after the break, there's going to be a mountain or a gray triangle, and we're just going to call it a mountain. That we stop moving when we collide with it. And if that happens, for now, I guess our score goes up. Probably want to show the score somewhere, right? Let's go create a score. I'll go up to the top. Create a variable called score, starts at 0. So that when we collide with that nugget, our score goes up. Score equals score plus 1. Though here in a few minutes, when we collide with the nugget, we'll just go to the cutscene. We'll wait a second and a half and then go to the cutscene. But right now we don't have the cutscene ready, so we can't go there. And I did want to show how to put a score on the thing. So to display our score, or really a HUD, we just don't have anything else to put in a HUD. Our heads up display. We want some information on the screen in most games, right? So to do that, we have to create a font. So it's something our game engine handles. Just like the images. So come up here somewhere. I'll put it by score. There's PyGame font init. So we have to initialize some sort of font. There's a default one, but we can include any font we want. There are millions of fonts in existence to choose from, but I'm just going to go with the default one here. Just the basic idea of a HUD, because of this list that I'm going to read off when we get to the end of class today. It's one of the main ones on the list. Then we have to choose which font it is, though we'll want to refer to it. So this next line needs a variable. Score font seems like a good name for it. And that'll be PyGame has a font object in it. And this is where we load in fonts. So one of the things we can load in is this font with a capital S and a capital F. And then the font we want. So it has to be something on your computer. Times New Roman is a good one a good fallback because of all the formatting, all the places that have formatting rules, most of them use Times New Roman font. So we can count on that being on most computers. And then a size, so maybe 29 pixels tall. I know it's all new and different, but this is what, do you see the pattern from what we've done before? See similar patterns? That's what you want to look for whenever you start, because at first you're going to have to go look up everything you get to do gaming. Don't try to memorize names. Look for the patterns. It'll make it a lot easier to remember things and make sense of what they're doing. Now that we have a font, we can come down after we draw everything else. We'll draw that on the screen. There's where we finish drawing our images. And then it's just we'll create one. So I'm going to create something called show score, which is basically the only part of a HUD we're doing. Normally there'd be a lot of stuff in a HUD, right? In role-playing games, there's going to be a huge list of numbers that we want to pay attention to on that HUD. On racing game, we want to see the speedometer, all that stuff. So very game dependent. In fighting games, we probably wanted to put a rectangle there, or two rectangles, right? A green rectangle on top of a red rectangle, so that we make the green rectangle smaller, corresponding to our health. But it would follow suit from this, just not with letters. And that is going to be that font we created, score font dot render, and then what we want to write in that font. So I'll put score concatenated with our score, which isn't going to run yet. I have to come back and fix that. False is anti-aliasing. Kind of outdated. It doesn't really do anything. It used to be a quicker way to prevent things from getting blurry. Yeah, we don't really do anti-aliasing. Doesn't do anything now that we've got all LEDs, and we can be pretty confident that nobody's going to be running this on the calculator too, because the LEDs aren't going to get blurry.
Really do, because I always see it in the settings, but always like when they're kind of like smooth the edges. Like pixels used to be square.
So this is what a diagonal line would really look like on pixels, right? There's our aliasing. Anti-aliasing. We double the pixels so that we end up with, or actually more than that. Sometimes we double our pixels. I forgot that one. So now it's going to look like a smaller thing, but it's a synthetic doubling because it doesn't correspond to the screen pixels, and it uses a lot of processing, and it has fancy tricks to make it look like we use twice as many pixels so that we get smoother lines. What you all say you're gamers? How many of y'all have a 4K screen on your system?
Oh my gosh, my laptop.
Or you probably wish you had a 4K screen, right?
Working on my TV.
Yeah, 1440 pixels, right? That's a lot. So if we tried to double that, it'd look like we had 1280 pixels. From if y'all saw what popped up in the chat right there.
I'm doing that.
Which we do have to do the processing for that. So it adds a lot to the processing. So even back in the day when it was really useful to make the graphics look better, it slowed things down. We only wanted to do it when we absolutely had to. What's the other thing I need to go with? Oh, then we need a color. It's like a light switch. So right, in binary, all zeros is all our light switches off. 8 red light switches, 8 green light switches, and 8 blue switches. All the room's gonna be dark. If they're all on, that's where we get white. So we need something that would represent those 3 8-bit binary numbers, or 3 numbers in 0 to 255. What we can fit in an 8-bit image. I should get that out of the screen since y'all keep looking up at this. I see y'all looking at the screens and I wasn't even paying attention to the Zoom stuff anyway. If we have equal amounts of red, green, and blue, it's gray. So closer it is to white, the brighter gray. So like A2, 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 which can't do hex here. So not hexadecimal binary. Something closer to white. A is 10 plus 2 would be 162. That's what I was just typing. 162, 162, 162 should be a light white, light gray. But still quite a ways from 255, 255, 255. And then we'll blit that. Scene.blit score plot. Somewhere on our screen, I guess near the top middle. So maybe 777. The middle of 300 is probably close to the middle. 300 and at the top of the screen, maybe 30 pixels down. And unlike our other images, we want to create this every time because our score is going to change, right? That string we're showing is different, and I forgot to do this. That's about to throw an error just for Python, but everybody said they saw Python before, so you've seen that part before, right? So I can concatenate integer and string. Probably seen that error message enough times, you know, just like I do. But that's another example. Notice how I'm not writing the code in order. The computer needs it in a specific order, but that is not the order I think about it in. So bouncing around, moving your cursor around, put it together in the order you think about it in, instead of trying to think ahead and think like a computer, because that's only going to confuse. It can be far more productive. I think we're ready to give this a test, right? Oh, I did add to the score, didn't I? Yeah. So every time we created the score up here, good to double check it since it came in question, and later we'll go to a cutscene when we hit that. But for now, we'll just see the score, and then that gives us an example of how we would build a HUD. It's painful to call that a HUD, but that's what we would want from me. Uh-oh.
That is exactly what I got. Argument one must be PyGame.surface not dot. But that line tell me. Doesn't like the same.
So sorry. Show score. We want the one we created from it. Sorry, I put score. I put the font there. The stuff, the letters we have to write with. But what we can actually put on the screen is the words we write with those letters. What? Oh, I didn't say. So mine was still running the previous one. Let's try saving that. Okay, there we go. That's a good spot for the score too. Oh, score should I probably should have started that at 0, right?
That is not what my score looks like. Oh.
So notice it keeps going up. We can set up different variables, but that tells us we're colliding. We should not be colliding here.
This is the hitbox.
Also, my score does not look like that.
Okay, so a couple issues to fix, but probably want to take a break first, right? We can tell a collision is happening, at least on mine. You want me to leave that on the screen? Or you already saw it, right? So
Yeah,
yours-
obviously, I need to look in this Sprite thing first. I didn't do that first.
Okay. The clock on the wall is wrong, but my clock, my laptop says 2:17, so that's an hour and 15 minutes now, right? Plus our visitor at the beginning. 10 minutes sound good? Quick break. Okay, so my laptop says 2:17. We'll get back to it at 2:17. That's the clock I'll watch. 2:27, yes.